Okay, so did you guys think about some project? We have got like two projects so far, three projects, and have you guys thought about some project? Okay, okay. I think we should start now. All right. Let let people join later on. Okay. So yesterday we were discussing about how do we do. Hi Chanmin, are you there? Yeah, I think he's not there. Great. So I'm starting now. Let others join whenever they get time. All right. So yesterday we were discussing about how to do streaming using using Apache Spark and using a library called dstream. Okay, which basically internally calls Apache, uses Apache Spark and does the job for you. Okay. Now, next step in this whole, so similar thing for stream processing, where you have lot of data coming in and you have to process it continuously to give results. And and such kind of thing was being done using a tool called Apache Storm. Apache Storm is more or less an independent system. It does not require you to install Yarn or Apache Spark or anything, because for Apache Spark you will require Yarn, and for Apache Stream you will require Apache Spark, and then you will require the Yarn. Okay. While for Storm, you don't require any other thing. It is a very simple system in which there is a master node and there are slave nodes, and the communication between master and slave happens via Zookeeper, the way we had described earlier, that you have a lot of servers and lot of clients, and how do they know each other, how do they discover each other. So that is facilitated by Zookeeper. Even if Zookeeper is not there, still Apache Storm will work decently. So at Amazon, we have built, as I was describing you yesterday about our problem, right, where lot of data is coming in the form of changes to the product details. So some merchant is saying that we have changed title, and then another merchant came in saying that we have changed a body and those kind of things. All right. So, and whenever that happens, we have to uh, you know run we have to run our algorithms to figure out what is the best image to show on the main page. Whenever you click on the product details page, you have to show the best images possible, and these best images are impacted by lot of parameters. So we, instead of computing the best image whenever user hits the URL, user clicks on a product, whenever user clicks on a product, say iPhone. So if we do the computation at that time, it used to take like 10 seconds or so. So instead of that, it used to take quite some time. After lot of caching and everything, we could not bring it down below 5 seconds. So to make it really fast, what we did was that we, for each product at Amazon, we prepared we prepared the images upfront, as in when the as and when there is a change. Okay. And that actually improved it. I made it like few milliseconds instead of seconds. So for that kind of scenarios where you have a lot of data coming in at fast pace and you have to show in the real time, like what is going on. In those circumstances, other than Apache, I mean the Spark's stream library, Storm comes very handy. If you do not want to install Yarn and you do not want to install Spark, Storm is your solution in those cases, right? It is basically to reliably process unbounded streams of data and can be used with any language. It has got fast benchmark and I mean they actually clocked it to one tuple per second per node. One tuple as in 1 million tuple as in 1 million rows of data. Okay, which is like a brilliant, really good, you know. And then it is quite scalable and fault tolerant, guarantees that your data will be processed. Integrates with queuing and other technologies. So actually, we built a similar kind of Apache Storm like system, not like a Spark, but more like Apache Storm. And Apache Storm is basically for real-time analytics, machine learning, continuous computation, distributed RPC, and ETL. So the way we write our code in here in the form of they call it sprout and bolt. Okay, and then each sprout generates the output streams of data while bolt aggregates it. Okay, and once you're done with that, then you upload your code to the Apache Storm and then it starts running. Basically, in very simple words, you define your individual units, like say uploading data to the network. To so uploading data to a network system. So this becomes one small unit. The second unit would be that second unit will be reading data from the queue. So all those things which can run in parallel, are built as small individual units, and then they are sent to Apache Storm. And then, so all of these things will either run in a thread or will run in a process. So that is what Apache Storm is. In case you need to, I'm just going, through the overview. So basically, before Spark came in very recently, and Storm has been there for quite some time, and is in use by lots of people. Okay, so when you have a need to process a lot of data, you can actually look at this Storm. I mean, whenever you have to do a fast processing of the incoming data, in those cases, Storm can be your one solution. Okay, and right. So I'll just do a bit of comparison. So in case of Apache Storm, as I was telling you, you make these small units called Sprout and Bolt. Sprout basically generates the data, while Sprout processes or Sprouts combines multiple, multiple streams of data. So you write your logic in that format, and then you can, uh, you know, and that at the end of it you store it back. The only thing is that when you are reading the data or writing the data back, you would require, I mean, for writing the data back, you might require kind of SDFS kind of solution, or similarly for reading the data, you might require SDFS kind of solution. So I'll just do a quick comparison between Storm and Spark. So So basically, with respect to the comparison in streaming, the processing model of a Storm is like a record at a time. Okay. And in Spark, it's like mini batches. Okay. Mini batches, as in are bound by the timeline. Because, uh, I mean, you remember that at the end of day, whatever data is coming in, it's stored in, you know, in whatever model it is stored in. There's an RDD which is taking care of it, and on each machine there'll be a window available to all of the people, and that is the mini batch. Similarly, the latency is less than a second. Okay, is less than a second in case of Storm. Latency as in when you launch a code, how much time does it take to just start the processing? I mean, the initial time taken. Okay, that I mean the beginning one, that is latency. So in case of Storm, it is less than a second, while Spark it is few seconds. Okay, so fault tolerance in case of Storm is that a record will be there could be duplicates as per the Storm's philosophy. That when you are processing stream, as per Storm philosophy, is that even if we process the one record twice, it is okay. While in case of Spark, that record will be guaranteed to be used only once. Okay. Now, so the origin of Storm has been Twitter, and there was Backtype before Twitter, the same company. And then the origin of Spark is University of, I mean, Berkeley. Okay. And Storm was implemented in a language called Closure, while Spark was in Java, Scala, and basically Scala. While API was Java in others in Storm, while in Spark it's Scala and Java. Okay. Okay. So as you can see that Storm has been in use since 2011, while Spark is fairly recent, like last year. And I mean, while one goes with the Hortonworks distribution, the other one goes with Cloudera. And so these are the basic differences between these two. And if you are looking for lightweight as a conclusion, when you have to take a decision which one to use, the my call is that when you need a lightweight one and you need more reliable as in something that has been in use for quite some time, you go for Storm. If you have already set up the Yarn framework, I mean, if you already have a Hadoop framework set up in your organization, then you might go for Spark streaming kind of an example. All right. And okay, so summary is that Storm has run in production of various companies for more time than Spark has. Okay. And while Spark has that, there is a company dedicated to it and it is compatible with Yarn. Okay. So if you have already the Yarn, I mean the Hadoop framework available in your organization, then probably you should go for Spark because it that will be far that can handle far bigger data as compared to the Storm. Okay. More reliable data because it has replications and all other facilities available to you. And or if you have Apache Yarn kind of framework I mean, when you have Hadoop installed in your organization, the chances are that most of your big data which you want to process is coming to coming to your coming by a Flume or something to your cluster. Okay, so it makes more business sense to you go for Spark if you have already Hadoop. So your data will anyway will in the HDFS. So it will make more sense to have Spark in that case. So that's pretty much. And here for further details, you should go through these links. Okay. Now, so basically, what I'm trying to do here is I'm trying to help you decide various kind of component when you go for a problem, for a particular problem. Okay. S- So this was with respect to Spark stream. I mean, this was with respect to the data streaming when you have to process data in the real time. Okay. Now when you are taking a call on NoSQL databases, this uh, quick comparison might help you guys. Okay. So first, let me just go over quickly how do you, when you look at the database, what should, click to you? The first thing should click you because almost all the database have similar functionalities, but there are the the stark differences between various database or stark characteristics which puts that difference. I'll be just highlighting those. So in case of NoSQLs, there is a database called Redis. So you use Redis when you have to do lot of in-memory processing. Okay. So Redis or SAP HANA, both of them are for in-memory processing. Okay. They are far, far, far faster than any other database because all of the data is loaded into memory with a disk based. In case computer crashes, you do not lose data. So that is the property of both. So whenever you have to churn lot of data in a single shot, okay, so whenever you have to churn a lot of data in a single shot, then probably Redis is your best solution available. Redis or SAP HANA. Redis is completely free, while SAP HANA costs you a lot, as well as probably SAP HANA comes with the hardware also. Well, Redis is open source and very, very easy to acquire and start using. As simple as that, you go to command prompt and say sudo apt-get install Redis, and you have Redis, and you can start using it right away. And then you can connect to the port on which Redis runs, and then you start using it. It's a very, very simple to use. Okay, it gives you a way to store values, and it's like a big, big hash table, which is in memory, and while having a having a disk support. Okay, so whenever you have to churn a lot of data in the memory, then you go for Redis. Okay, and I mean, as for example, that we were, let me take a call of, say, you have real-time stock prices. Okay, real-time stock prices means that, say, you have to just compute top three, top three stocks at any moment of time. You have to display top three stocks at any moment of time. And this data, what the stock prices, that they can be stored in the memory, right? In those cases, say 80 GB memory you have, and you have computed that we will be able to fit in 80 GB RAM. Okay, because today 80 GB RAM is not new. What is for IMDGs? In-memory data grids, yeah. Yeah, you're right, Twain. So mostly in-memory databases, You have all of those support the sort of mirroring on the disk. Okay, mirroring on the disk immediately. So all you need to do is while starting up, you just need to mention that you want a snapshot on the disk. Okay. So say for example, you need to just keep top three. So those who are from a background like background of computer science, they would know what does it mean by a heap, right? So all of the whole heap has to be maintained in the memory, okay, or any big large data structure. So in those cases when you have, it is inevitable to maintain a lot of data into the memory because you cannot afford to lose time in reading from disk or from network, not even half a second. In those circumstances, all these databases like Redis and all come in very, very handy. And also, your data is not that big. Your data is big enough to fit into the RAM. In those cases, Redis and SAP HANA are really, really brilliant solutions. Their performance is 1,000 times than that of other databases because a RAM read speed, the speed at which you can read from a RAM is more than 1,000 times the hard disk. Okay, more than actually 1,000 times, probably 10,000 or something. Now, so this was Redis. So you got the idea, right? When do you use Redis kind of solutions? Now, because lots of people asked me that can I give a quick overview of various components so that it becomes easier to take a call which one to use when. That is why I prepared these couple of slides. Okay, so because this is not a part of our standard Hadoop curriculum, but it is a part of your when you are a developer or you are somebody who is taking a call on deciding various components, these come very handy. Now, there is a database called MongoDB. Okay, so MongoDB's primary role is that it is a document-oriented database. Whenever you think about MongoDB, think about a document-oriented database. Document-oriented as in each document is sort of an object like you have in Java or like you have in JavaScript or like you have in other programming language. So each, instead of a flat row is like a flat thing, right? Where there are n number of values. And right. In case of MongoDB, that each row is a basically document. You the way you add a row in the table or update a row in the table, you say add a document or update a document. A document can have key value pairs, okay, and value can be further another object. So, so it becomes a very interesting problem. And on the top of it, it provides you indexing on key or the or the or the key of the main object or key of the sub object or key of the sub object. Okay. So so that makes it possible to actually find an object very, very quickly based on the parameters of the object itself or parameters of a sub object. Okay, object inside object. So the way, I mean, that's how an object is defined, right? So every object has sub objects as part of it, right? Now, right. So Gunjan, this one is not Google Big Table. MongoDB is not that one, but HBase is the Google Big Table. All right. HBase is the identical copy. If we went through HBase quickly, okay. So in case of MongoDB, it is more like you prepare, say for example, you have a Facebook kind of a application. Now, most what happens mostly is that I think I went through the screen. Yeah. So what happens mostly is that you are joining hundreds of tables to prepare a single page. All right, you are joining like hundreds of tables if you are going via relational mode. So now after some time, what will happen is you will start preparing these pages and start caching them. Okay. So instead of doing that, what people have started doing is that they prepare a large objects representing an entity or a page and then save them in a separate database. Okay. And that's where the MongoDB like things come very handy. So instead of joining every time a request is coming, you prepare the whole object and keep it ready for rendering. And actual HTML rendering, you just render that object in the HTML and you are done. So that's a pretty interesting proposition from MongoDB. It is best used when you have dynamic queries. You prefer to define indexes, not MapReduce functions. If you need good performance on big data, you might want to use CouchDB. Okay, but your data changes too much and fills up disks. Okay, so CouchDB and MongoDB, there are similar concept like MongoDB in CouchDB also. And CouchDB basically takes uh, okay, does more writes than MongoDB, but they are almost similar in behavior. Okay, and both are well supported. And I found out of both the things, MongoDB was really well supported and have is pretty good. Okay. Okay. All right. So this is the form of objects you have, like first name, last name. This is one object, and under address you have this another object. So this is the kind of object you can define and save. And this comes very handy because say tomorrow you have to include one more here, like street address one more here, and so you don't have to change all existing objects. Okay, because every other object can have different number of parameters. Similar to HBase, while we were talking about HBase, we could add more parameters. Okay, we could add more parameters. Now, this is fine. So we talked about Redis, we talked about MongoDB, and CouchDB is also similar, but not that well supported as MongoDB is. Now, Cassandra is similar to HBase. Okay, similar to HBase and is like close clone of SQL, standard SQL. So whenever you have to store a lot of data and you find it more comforting to have relational database than any object-oriented database, then go for Cassandra or HBase. If you already have a Hadoop cluster which is dedicated to you, then HBase is your choice. Okay. I mean, between Cassandra and HBase. So first, let's talk about when do you need Cassandra and HBase? When you require a closest clone to your standard SQL, but something which can handle a lot of data and where you know in and when you have lot of data, when we say lot of data, which means millions rows by some uh, hundreds of thousands of columns. Okay, million rows and hundreds of thousand columns. Yes, it has a dynamic schema like MongoDB, as in two different rows, two rows of the same table can have different set of columns. Okay, but that's up to you. But most people prefer to have the same number of same columns mostly, and the API, what people have done is whatever like Hibernate APIs we had earlier, by Hibernate mappings we had earlier, people have developed similar kind of APIs or similar kind of ORMs, object to relational mapping softwares between Cassandra and your Java, so that you do not, you still can keep on working the way you were working earlier without touching it. Okay. So that's about Cassandra and HBase. And between HBase and Cassandra is okay. Between HBase and Cassandra, what you need to do is if you need to decide between HBase and Cassandra, the very simple rule is if you have a Hadoop cluster already in place, then go for HBase. If you don't have a Hadoop cluster in place, then probably and you're free to. I mean, then you would prefer to go for Cassandra because Cassandra is lightweight and it doesn't require you to install a Hadoop cluster and all, while HBase would require that. That is a quick call you can take between HBase and Cassandra. And performance-wise, both of them are similar. Okay, performance-wise, both of them are similar. And there is a company called Data Stacks. Data Stacks. So who is supporting them? I've used Cassandra in for like brief period of 3 to 4 months when we were building something other than recommendation after recommendation during InMobi. Okay, I mean in particular this tool InMobi Analytics. So okay, this tool when we were building it, I mean that time we had no plans of launching it that instantaneously. And these actions you see, these actions is what I built here. Okay, while insights and segments we other two guys were building. So the prototype I wrote that part. Okay, and this one analytics on the back end we used Cassandra, and in the beginning people found it is stupid to see us that we are using Cassandra. But when we showed numbers like these are the users which we are expecting based on our advertising, because we had a lot of advertiser apps and we were giving this app for free to them. And then when we showed the numbers, like this much record we will be storing, because we had like 10,000 small advertiser, and each advertising app is going to send at least 1,000 uh, entries every minute. Okay, which means that it is going to store huge data, and that is the reason why we choose our Cassandra instead of. And the difference between HBase and Cassandra, we as I told you that we did not have to set up Hadoop cluster, and all we had to do is we just needed Cassandra. But now when I think about it, probably HBase would have been also a great option. Okay, but that time Cassandra was like we compared both HBase and Cassandra, and Cassandra was far better supported than HBase. Okay. So we used those kind of I mean Cassandra in this project. All right, so that is about Cassandra. Okay, okay. So why not MongoDB? The reason was that we were looking at a close clone of SQL. Okay, some of the teams like Insights and Segments team, they were far more comfortable with ORM, and here most of it was flat files. Okay, we did not have to develop too much. So that is the reason we had actually chosen Cassandra over MongoDB, right? Because these were very close clone of relational databases. And also this guy has I mean, similar to MongoDB, Cassandra, as opposed to HBase, it has tunable consistency. As in, when people say that my database lies in out of these three, we can have these two. Cassandra has a tunable consistency. If we want 100% consistency, we can tune that part, and that was one benefit over HBase. Now, similar to Cassandra, we have HBase, and again, HBase is whenever you require billions of rows and millions of columns. Okay. I mean, with respect to data storage and data handling, HBase has far, far, far bigger limits than any other system. The only thing is you should use HBase only if you have billions of rows and millions of columns. Okay. So if you have that bigger data, only then you should be actually touching HBase. While MongoDB and most of the smaller databases can be used even for very, very small data. Right. And okay, so when you have a huge data sets which you find it impossible to handle on all other scenarios, then you should go for HBase. Okay. And these are the few use cases, like you have search engines, then analyzing log data, and then so so the question which our uh, Venkat Williams has posted, probably they can build it upon HBase. Okay. And here the other thing is HBase, when you do a churning of the data, it is done using MapReduce. And and when you use the MapReduce for doing lots of your job, there is a latency involved. All right. So anyway, when you are talking about billions of rows and millions of columns, the l- latency of few seconds or few seconds will not matter at all to you. Okay, because the other aspects are pretty fast. Okay. So this is what HBase's use cases. And okay, and similar to HBase, you have Accumulo and Hypertable and Cassandra, and probably uh, you should go through this one. There is a beautiful URL. I find it really useful to any beginner when you compare databases, because this seems like a perennial question: which product, which database to use. All right. So hope I did not further confuse you. Okay. So in a very quick way, Redis, it's an in-memory database. SAP HANA is also similar to Redis, and MongoDB is a document-oriented database. Okay, it can be used for a smaller data, not only for the big data, and it provides you a lot of in-memory functionalities also. Okay, so whatever RAM is available, this tries to use it and perform it. Okay. That might suffocate other processes running on the same machine as MongoDB. Now, Cassandra, storing huge database in almost SQL-like format. Similar is HBase for billions of rows and millions of columns. And for HBase and Cassandra, you have got those ORM drivers. Okay, similar. I mean, like Hibernate. And now the next point we are going to discuss is the project. So I've got some four, five, uh, I mean, three entries basically. Okay. So these are the three suggestions I've got. I've got one suggestion for Gunjan. Okay. Gunjan is also, Gunjan has sent a project detail about his. I'll write that down and we'll discuss it further. First, I need to talk to Gunjan. And then And probably whosoever has replied to the email I sent yesterday, okay, and so I mean, okay. Okay, so in case you have not replied to that email, please reply to that email, because I'm assuming that in case you are interested in project, then you will reply to the email. All right. So in case you are interested in the project, you will reply to the email. Okay. And otherwise, I'll have to, because anyway, for the certificate, right? For the certificate, you need to do at least one project. Okay. So these are the projects I have got so far. Okay. If you have something in mind, just please feel free to write to me. And and once I have got confirmation from I mean, there are few more emails pending. Once that happens, then we can start. Okay. So I'm expecting that your confirmation of project or project start date from Thursday. Okay. So drop your email if you're not written yet. Drop an email immediately. Okay. And then next is that next Saturday we have a first update on the project over the email, and then the last date of assignment completion is next Sunday. Okay. Next to next Sunday. Okay. Okay, this is assignment completions. Remember, this is assignment completions, which means whatever assignments we has been assigned during classes, please finish those assignments. And then this last date of submission is after 14 days, meaning next to next Saturday. All right. And once you have submitted that, in 7 days of the all the submission, once you have finished both the submissions, then expect the certificate within 7 days of the submissions. All right. So this is the more or less the plan of with respect to timelines, and and then you have to, if you have not decided, so you have Thursday till Thursday evening to decide upon your project. And after 14 days of starting, not today, you can keep the last date of submission. All right. Because we were planning to start on Thursday. After 14 days from Thursday, it will be your last date of submission. Okay. You will have the access to the, you'll have access to the cluster. Okay, so you can experiment, test, and if you have, questions about learning something, say for example, you're not confident about certain things, like some queries in Pig or something in Hive or HBase, you should finish that part now, and that will happen only if you just go through the assignments once more and try to solve those assignments. Okay, so So that is with respect to dates, and those who are, planning to, trying to find out some project have not been successfully able to do so yet. They can go through the large databases available to public, and you pick up any of the data set, and think of a project involving. Okay. And once you have decided, and if you have any other thoughts in mind, then let me know. On the Thursday evening, we will finalize the teams. Okay, finalize the teams and the projects. So far, I have got emails from only these people, which means they are interested in project. And Iraya, should I assign you some projects, independent one? Okay, okay. Let me see. Okay, okay. Okay, so we will plan, and then I'll drop you an email. In the meantime, feel free to, in case you have left out something in the introduction, or if you have come up with a better idea, let me know. Okay. And accordingly, I will assign the projects. Okay. So probably I'll form a team of three. Gunjan, I'll need to discuss things with you. I'll talk to you maybe today. All right. So great. So this is pretty much from this side, my side. All right. So that closes the course of Hadoop. And in case you have doubts, just drop me an email. Okay. Just drop me an email and we can discuss. Okay. So, drop me an email at either Sandeep at No Big Data or prefer Hadoop at No Big Data as the email ID. Okay. So feel free to communicate in case you have any doubts with respect to any of the topics which we have gone through. Okay. And stay connected even if this course finishes. That does not mean the relationship ends here. Okay. Stay connected because the way I foresee this organization like No Big Data, I foresee that a lot of interesting things are happening. A lot of interesting things are happening. So stay connected as in maybe on the groups which we have formed on Google Plus. Maybe you can post there or or you know drop me an email from in case you have any doubts. But stay connected. This does not end and finishes the key. I mean, I sold a course and you bought a course and the relationship ends. That's not the way it works. Because there are multiple ways, right? So in plans of future, Gunjan, first, what I'm trying to do is I'm trying to connect to the industry. A lot of people like IT's Infotech, HP, then Morgan Stanley, then Mphasis, then there is a and Dell itself. But it's things are not with respect to Dell, it's not there yet. But with other companies, it's going good. So I'm trying to connect with the industry and see what kind of work they need input from us, so that if someone of my teammate or my student is interested, I can those student can help them out, and in this manner the students get an experience working in big data and more confidence in handling the big data task, while and they get benefited, right? So that is the idea. So when lots of people are asking me that if I can help them out, so my role is like of an advisor, and then my plan will be that I hand it over some work to the ex students or current students. Okay, everybody gets benefited, and in case some career opportunity arises, also they can move forward. Okay, so that's a kind of thing. Other than the courses, with respect to courses, if that could be another question. So we are planning to launch data sciences course, and these small independent topics like Apache Spark, Apache Storm, we might launch as independent one. Okay, and some of the courses which are not as exhaustive as Hadoop, some of the courses might be independent video courses. Okay, because I mean, in case any of you is interested in further and has really done a good job with respect to your assignment, then and want to stay afresh and want to be the TA, I mean a teaching assistant with me, let me know. Okay, so that is how it is. So most of the assignments are reviewed by ex students mostly, who did their assignment really well. So in case you're interested in that also, then you can join. Let me know. Okay. Say for example, in case of MongoDB, there's a lady called Samta who did her assignments really well and wanted to stay connected with MongoDB, database per se. So she generally reviews most of the assignments and does. Similarly, she's also mentoring couple of people, and she's also, not mentoring with respect to database, but with respect to the technology. She's learning day by day. So although she's a TA, but she is doing a project again with the candidate so that she can um, you know stay connected with the industry. So in that manner, if you have a similar aspiration, so let me know. Okay. So there are more than one way and more than one possibilities. Okay, that will arise and that will help. All right. So I mean, stay connected. Drop me an email, and maybe I may not be able to reply immediately, or I may not be as comprehensive in replying, but I'll reply. In case it's urgent, I'll reply immediately. In case it's not urgent, then I'll just I might take a few hours of time. All right. And Gunjan, I'll give you a call. Okay. So feel free to drop me an email in case you have any doubts or confusions, and stay connected on the Google group or on anywhere else. And also feel free to refer your friends. Okay, feel free to refer to your friends because I mean the way most of my classes are working is through referrals. All right. And instead of spending money on the sales, we give it back to the students as 10% referral bonus, and 10% is the discount given to the candidates. Now, so that's pretty much from the marketing side. Okay, great. So we'll finalize the project and drop you all an email. And in the meantime, if you have come up with something, just drop me an email. So Thursday evening, before Thursday evening, we will finalize everything. Okay. And also keep your eyes open. Keep your eyes open in case you have got a great idea and you want to work upon it. Okay. Because that's how things are working out. I mean, there are a couple of candidates from the other course, the first course basically. They have just started up, and that whole thing started as a project in a, in a in during our session. Okay, so they have just started up there. Right. So they're just building something interesting, and he wanted to, seek inputs from me. So there could be multiple ways in which we could get benefited from each other. So stay connected. All right, and feel free to also write a testimony on the Facebook page. And I'm really thankful to some of the friends, some of the candidates who have written a good testimony for me, and that's encouraging for me I mean, to do better than what I've done now. Okay, so that's pretty much from my side, and feel free to connect anytime. Okay, so okay, so do you have anything else to say? Okay, great. Thank you, Gunjan. I also like that. So feel free to write our testimony on this nobigdata.com Facebook page. Okay, there you can there. So this is okay. Where is my compose window? So this is my okay. And also you guys should stay connected together as a class. For that you can use the Google Plus group. That Google Plus group is for all the access students as well. Okay, great. Bye bye guys and have a good day. So that sums up our class today. Okay. See you. Bye bye, Tuhin. Bye bye, Gunjan. Bye bye, Arun. Bye bye, Raya. See you, Tranmin. Have a good day. Bye bye, Jimmy. Bye, guys. Have a good day.